The title for this afternoon's webinar is Natural Ecosystems from Land to Sea, and our two speakers are Terry Hughes from James Cook University and Steve Williams, also from James Cook University. And so actually this webinar is coming to you from the campus at Townsville of James Cook University. So as you know, at any point in the webinar, you can lodge your questions by using the on-screen question and answer box next to the video stream. And the video of this webinar, should you miss anything, will be made available on the NCARF website in coming weeks. So in this webinar, the first speaker after myself will be Terry Hughes, and talking about the marine environment, and the second speaker will be Steve Williams talking about the terrestrial environment. I'm just going to do a really quick introduction, just first of all to give you a bit of background about NCARF and what we do and why we're putting on this webinar series, and then just a few introductory remarks about the topic of this afternoon's webinar. So NCARF has the role of developing and delivering knowledge to support adaptation in Australia and to build capacity among the adaptation research and practice communities here in Australia. And we do this through a whole range of mechanisms, but the webinars that we've been putting on are built around a stream of information delivery, not only for decision makers and policy makers, but also for communities, for non-governmental organisations and so on. So the topic of this afternoon's webinar is natural ecosystems, and there are two publications by NCARF that I'd just like to draw to your attention. We produce synthesis summaries, which are 16 pages long, and they synthesize current knowledge around an important topic in adaptation. And they're based on outputs from a series of research projects that took place in NCARF during our first phase, which ran up to 2014, and also on more recent research that has taken place since 2014. And these summaries are designed to be accessible, authoritative and attractive. You can access them at the web address shown on this slide, and the one of interest this afternoon is the one on terrestrial ecosystems. We also do a series of what we call policy information briefs, and we have done one on the Great Barrier Reef. The policy information briefs are much shorter, they're only about 6 pages long, and they target key challenges and locations under climate change in Australia, and they focus strictly on the knowledge needs of policymakers in state and federal government. So just then to say a few remarks about the topic of this afternoon's webinar. I'm not an expert by any means in natural ecosystems, so when I was thinking about what I might say this afternoon and what our two speakers will be going to say, then the automatic point of call for me is the Fifth Assessment of the Intergovernmental Panel on Climate Change. And I'd just like to show you 3 slides from the Summary for Policymakers for Working Group 2, which deals with impacts, adaptation and vulnerability. And this all came out around about 2014. So this first one is around observed changes in natural ecosystems that can be related to climate change, and it's for the oceans, and it shows the change in distribution of marine taxonomic groups over the period 1900 to 2010. And you can see the horizontal line on the slide, and basically if the bar is above the line, then that indicates that these taxa are responding to warming. They're actually moving in a poleward direction in order to maintain their environment at approximately the temperature that they are acclimatized to. So as you can see, just about everything that sits in the oceans at the present time has moved in a poleward direction over the period 1900 to 2010. There are clear observed changes in the marine environment that we can document in a very quantitative manner, and Terry will be talking a little bit more about that this afternoon. If you look then into the future, you can also see that changes are predicted through models to be about to take place and to take place in the future up to the duration over which the models run, which is about up to 2100. And this just shows you how able species are to move compared to how fast temperatures are expected to change in the terrestrial environment. And it's shown for various scenarios looking out into the future. And what it tells you is if the bar is short, and especially if the bar ends below the lines which indicate temperature changes, the amount of temperature that's going to take place, then whatever you're looking at is in trouble. So you can see that the short bars are for plants, for trees, and for small animals that are not able to move very quickly. And they are seriously threatened by the rate of change of climate, of temperature, looking forward. Large mammals and creatures which fly are in a somewhat better position. And finally, just before we move on to the talks by our two speakers, this just shows you something about the key future risks in the oceans. And they're pretty much what you would expect, really. So they show you that the IPCC identified 3 future key risks in the oceans. One for the distributional shift in fish and invertebrate species, one for the risks to coral reefs, and one for coastal inundation and habitat loss. And the risks are shown for 3 time periods looking forward, and the length of the bar shows you how great the risk is expected to be. You can see that at the end of the bar, for some of them, there is a sort of cross-hatched or hatched area, and that indicates what might be achieved through adaptation. And I guess I will point you to look at the risks to coral reefs looking forward, and you can see that the bar is very long, especially as you approach 2100, the end of the century. It's very long, and there is very little, if any, scope for adaptation to reduce the risks. So that's all that I want to say as an introduction, and I'm going to pass over now to Terry Hughes, who's going to tell you more about the marine environment and I guess coral reefs in particular. So if I just say a little bit about Terry, he's director of the Australian Research Council Centre of Excellence for Coral Reef Studies at James Cook University, and his research focuses on the linkages between the ecology of reefs and their importance for societies and economies. He's worked extensively in Australia, the Coral Triangle region, and in the Caribbean. An important aspect of his research is understanding the dynamics and resilience of coral reefs and translating this knowledge into innovative and practical solutions for improved reef management. Terry.
Thank you. I'll take this.
You can.
Gizmo. Hello. I'm going to talk for about 10 minutes, and I've been asked to speak to the question, what is the life expectancy of the Great Barrier Reef? It's actually a question I'm asked quite often. Will we have a Great Barrier Reef? Will the world have coral reefs in 50 or 100 years' time? So in Australia in the last 2 years, as I'm sure many of you are aware, we've seen 2 back-to-back coral bleaching events. We've actually had 4 events now in the last 20 or so years. The first was in 1998. That was a real wake-up call for Australian coral reef scientists because it was the first time we'd ever seen a bleaching event. It happened again 4 years later. Then we were lucky enough, in hindsight, not to have any bleaching for 14 years. And now, tragically, we've seen the first back-to-back bleaching in 2 consecutive years, this year and last year. 2 of those years, 1998 and 2016, were El Nino years, but the other 2 were not. And increasingly, what we're seeing around the world is bleaching events now occurring throughout ENSO cycles, even in La Nina periods when temperatures are slightly cooler. And the reason for that is that in the tropics, La Nina years now are warmer than El Nino years were 30 years ago. So the cause of these bleaching events is not El Ninos per se, it's global warming and increases in temperature. So I'd like to show you a short video of what bleaching looks like from the air. So in March 2016 and again this year, I spent 7 days flying the length and breadth of the Great Barrier Reef, documenting the footprint, the geography of these two massive bleaching events. So what you're looking at here is footage from a helicopter in the northern third of the Great Barrier Reef, where the bleaching last year was very extreme. So bleaching is a stress response by corals. They turn white because they lose the color that they get from the microscopic algae called zooxanthellae that live inside their tissues. So a bleached coral is nutritionally compromised, and if the bleaching lasts longer than a few weeks, we start to see mortality of corals, which in 2016 and 2017 was quite extreme. So we also measured the extent of bleaching underwater, and this graph here shows the relationship between the level of heat exposure on the x-axis using a metric called degree heating weeks, and the y-axis is the percent bleaching we observed while diving underwater, and each of those dots is a different reef. And you can see a very strong relationship between the amount of heat stress, the amount of heat exposure, and the level of bleaching that occurs underwater. And we've published our preliminary results on the extent of bleaching in 2016 in the March 16th issue of Nature. Tragically, 2 days before that paper came out, I got back on an airplane and a helicopter to resurvey the second bleaching event. So this is our preliminary data for the two footprints of the bleaching in 2016 and again this year in March, April. So the red dots are bad. That's where the most severe bleaching occurred. More than 60% of the corals were affected on reefs that are red. And the green dots, that's good news. That's reefs where less than 10% of the corals were bleached. So in 2016, we saw bleaching that was very much a northern affair. North of Cairns, all the way up into the Torres Straits, up to New Guinea, was very severely bleached, but the south escaped. And in 2017, we have a different geography, relatively mild bleaching in the north, but severe this time in the central region, and again the southern region escaped. Those two footprints can be explained very precisely by where the water was hottest in each of those 2 years, and the same is true for the events in 1998 and 2002. But between those two events, this year and last, fully 2/3 of the Great Barrier Reef has now been severely bleached in just a 12-month period. So a key question is how many of these bleached corals survive and how many die? And we haven't yet published that information because the bleaching is actually catching up with our ability to collect the data and to publish it. So here is a preliminary graph of the mortality, which we published in the Conversation with my colleagues from the Great Barrier Reef Marine Park Authority and AIMS, the Australian Institute of Marine Science. So it's a map showing the extent of mortality in 2016, and it's color-coded. So the green area in the south had no bleaching and very little mortality as a consequence. The opposite extreme occurred in the north. So the red region, which is about 700 kilometers long, experienced a median mortality rate, loss of corals, of 67%. When bleaching occurs, it's actually very selective. Some species are much more susceptible than others. So the more susceptible species in the north, in that red region, have suffered mortality rates in excess of 80%. The mix of species has changed. It has probably changed forever, because the likelihood of getting a 4th, 5th, and 6th bleaching event in the 10-year period that it takes for these corals to recover is now extremely high. And of course, we have now seen a back-to-back bleaching. Across the entire Great Barrier Reef in 2016, 30% of the corals died. That includes the southern region where no corals died. And this year, our preliminary estimate of mortality, mainly in the central region, is 19% mortality across the entire Great Barrier Reef. Those reef-wide figures, I think, tend to underestimate the losses. Basically, we've lost close to 2/3 of the corals in the north last year and close to 50% of the corals in the middle section of the reef this year. And the sobering thing about these losses is that they have occurred with approximately 1 degree of average global warming since the pre-industrial period, and global warming, of course, is continuing apace. So Australia has a plan called the 2050 Reef Sustainability Plan, which is the major framework for managing the Great Barrier Reef into the future, hence the name 2050. The objective of the plan is to improve the World Heritage Values, the Outstanding Universal Values, or OUV, of the Great Barrier Reef World Heritage Area decade on decade into the future. However, the OUV of the Great Barrier Reef have just been severely damaged because all elements of the World Heritage Values of the World Heritage property depend on healthy assemblages of corals. So I would argue that the objectives of the 2050 plan are no longer achievable, and they need to be reformulated. Specifically, I believe the goal of the 2050 plan should be to be more forward-looking, to preserve the Great Barrier Reef in a changed condition so that it remains functional into the future. So the plan needs to be more forward-looking, because maintaining the values of the reef that were there when it was inscribed as a World Heritage Property in 1981 is no longer achievable. The plan needs to address climate change as well as water quality, which is the current major focus of the Great Barrier Reef. So returning to the question, what is the life expectancy of the Great Barrier Reef? This is a question that my colleagues and I are asked repeatedly for many years now. And coincidentally, we have just written a paper about it. So in the next couple of weeks, we'll publish this review paper called Coral Reefs in the Anthropocene in the journal Nature, which will address this question. So I'll just finish up by giving you a very brief summary of what this paper says. Firstly, we argue that reefs face a climate gauntlet, that they will transform but not disappear under the COP21 climate targets. So those targets, as you know, are for achieving a global average temperature of somewhere between 1.5 degrees centigrade and 2 degrees centigrade. Now, there's quite a lot of confusion about what those degree centigrade numbers mean for the tropics. The level of heating captured in the COP21 targets is the global average. So it includes tropical waters, tropical land, and of course the poles. It's the whole planet. And an important point is that if the world does warm by 2 degrees, tropical oceans will warm by a significantly lesser amount. So far, tropical oceans have warmed by about 0.75 degrees centigrade on average. And under the COP21 2-degree target, they will warm by another 0.5 degree centigrade. Clearly, the 1 degree of warming which has already occurred is not a comfortable place for coral reefs. We're seeing more and more bleaching. But I do believe if we achieve the COP21 targets, that we will be able to maintain functional reefs, but they will be very different in terms of the mix of species of the reefs that we see today. So I believe our goal should be maintaining functional reefs, which will require a radical change in how we do coral reef science, management and governance. And a big challenge is looking after reefs, not just in terms of global warming, but also the other major threats that they have to endure, particularly pollution, which is the major focus currently of the Reef 2050 plan, and also overfishing. So I'll drop that slide and just conclude. So I would argue that the 2050 plan needs a radical overhaul to acknowledge the impact of global warming. Coral reefs do have a future, but it's a very different future. The mix of species that was observed on the northern Great Barrier Reef before April last year is probably not again attainable in our lifetimes. Climate change remains the elephant in the room in terms of management strategies around the world. Climate change and other key drivers need to be wound back to be decreased, and they need to be incorporated as additional targets in the Reef 2050 plan. And finally, we have to stop emphasizing band-aid approaches. The elephant in the room is climate change, and that's what we need to address to secure the future of the Great Barrier Reef. Thank you very much.
Thank you. Thank you, Terry. Very interesting. Can I just ask a question of my own before I begin on the list I have here? Would you like to define gimmicks?
Gimmicks are generally very small in scale. So many people have been proposing quick fix ways of protecting small patches of reefs. So it might include outplanting of corals that have been bred in an aquarium. It includes culling crown of thorn starfish on a very small number of reefs, currently 22 out of 3,000. It includes putting shade cloth over reefs, pumping cold water up from the deep. The problem with all of those solutions is they're not scalable. So no one has restored a hectare of coral reef. And in 2016, we saw incredible damage to 700 kilometers of reef. If you scale up the cost of the current small scale efforts, we'd be looking at billions of dollars to restore just a handful of reefs. So prevention is much better than cure when it comes to securing a future for Great Barrier Reefs. And we need to actually deal with the drivers of change, which is principally climate change, pollution and overfishing globally, in order to secure their future.
Thank you. So there is a question here about runoff onto the reef and the extent to which it's a threat compared to climate change.
Yep. So the 2050 plan currently focuses on runoff and pollution, which is a very good idea. But 2 points. One is the severe bleaching we saw in the northern Great Barrier Reef last year and in the central Great Barrier Reef this year paid no attention to water quality. So nearshore muddy reefs in the north last year bleached to the same extent as offshore reefs in crystal clear water. So water quality doesn't affect the intensity of bleaching. Where it is likely to have an effect is in the recovery afterwards. So a muddy reef is likely to have impaired resilience, an impaired ability to recover after a bleaching event in the decade or so afterwards. But obviously that recovery also depends critically on whether we get a bleaching event during that recovery period. So we simultaneously need to look at multiple drivers, not just the ones that are more tractable.
So on the same theme, are there physical or mechanical ways of helping the reef to adapt?
I think what we're seeing on the Great Barrier Reef and on reefs worldwide is a huge global experiment in natural selection. So we lost roughly a third of the corals in 2016. That means 2/3 of them survived. And assuming that those 2/3 on average have a greater heat tolerance than the ones that died, we know that corals are genetically diverse. We know that there is some heritability for heat tolerance. Natural selection is certainly underway. We also know that the threshold for bleaching varies in different regions. It's strongly related to the average summer temperature that is experienced in different locations. So there is clear evidence for local adaptation currently. And that's why when the temperatures of reefs stabilize with a COP21 target, that there will be a capacity for reefs to slowly catch up. But I'm talking about a 2-century gauntlet that reefs will run through. So conditions for reefs will get worse before hopefully they get better, but it's entirely contingent on the success or otherwise of the COP21 targets.
So can corals migrate? Is there anything we can do around relocating or helping corals to migrate in some sense?
Well, corals clearly can evolve, and yes, they can move. So we know from the fossil record that in warmer periods, reefs expand into subtropical regions as they warm. That's already happening now. It's happening on the east and west coast of Australia, it's happening in the Caribbean, along the east coast of the United States, it's happening along the Ryukyus chain in Japan. What we're seeing though is individual corals migrating or species ranges expanding. We're not seeing the expansion of coral reefs per se, and there are some barriers to that happening. That will happen naturally, the same way that natural selection will happen naturally, and it will happen on a very big scale. So the issue for artificial migration and for artificial selection is that it simply can't compete in scale with what's already happening naturally. So if we have 60% or 70% of the coral surviving a major bleaching event, that means that those survivors are producing billions of larvae each year, and the small amount that we can breed in the laboratory and add to that gene pool will be trivial. It's not going to change the gene pool beyond what nature is doing.
So the elephant in the room to me seems to be, you've talked a lot about COP21 targets, and Australia has its own COP21 target, but actually Australia's ability to influence the global change in emissions is relatively small.
Yeah, when I say target, I mean the temperature target.
The temperature target.
I don't mean the individual pledges that different countries are making. And of course, Australia's pledge is a very weak one compared to other wealthy countries. So certainly there's plenty of scope for Australia to vastly improve its renewable energy targets. So to my mind, an appropriate policy response to back-to-back bleaching of the Great Barrier Reef would be to speed up the transition away from fossil fuels to renewable energy in Australia and elsewhere.
But given that Australia is a relatively small contributor, albeit per capita it's very large, to overall emissions of greenhouse gases, what is it that the Australian government or what Australia should be doing around preserving or saving the Great Barrier Reef? What is it that needs to be done within that context?
Well, I mean, that's a very good question, Jean. It's of course a global problem. So the bleaching of the Great Barrier Reef wasn't just caused by Australia's emissions, it's caused by global emissions. But I think Australia in the coral reef realm has a special role to play. Most coral reefs are in small, developing, relatively poor countries. Australia has the capacity and the wealth to do things beyond the capacity of many other countries. So I think there's a leadership role for Australia to play in terms of leading the charge for better global stewardship of coral reefs. The Great Barrier Reef is intensively managed, but as I said, the elephant in the room is the threat to the Great Barrier Reef of global warming and climate change. So I would like to see Australia take a much more proactive role in leading the charge towards the transition away from fossil fuels. But of course we have proposals to open new coal mines in Queensland, which will definitely have an impact on the Great Barrier Reef, not just through the emissions, but also from dredging and a doubling of the amount of shipping of coal across the Great Barrier Reef. So there's certainly opportunities there for Australia to show some leadership and to give the Great Barrier Reef and other reefs around the world a fighting chance to run this climate gauntlet and to secure a trajectory away from business as usual greenhouse gas emissions.
Thank you, Terry. Okay, so we'll move on to our second speaker now, who is Steve, and there will be opportunity to ask Terry more questions in a little while when we open the general discussion at the end. So Steve Williams is a professor in the College of Science and Engineering at James Cook University. His research is focused on field-based ecology, understanding biodiversity, assessing the resilience of natural ecosystems to environmental change, and using this knowledge to maximise the positive benefits of conservation management and adaptation in the face of a changing global climate. Steve.
Thanks a lot, Jean. Thanks everyone else for joining us as well. And I guess I'd like to now sort of tell you a bit of the story about what's been happening and what's likely to happen in terrestrial ecosystems, which is, of course, very complementary to what Terry's just been talking about. In fact, I would like to emphasise that I could not agree more with most of the comments that Jean and Terry were just talking about about controlling emissions, mitigation and reducing emissions is the key globally. We now live in what's commonly called the Anthropocene. It's a state of the world where humans have now changed the world so much that we rival any of the great periods in the past. Global biodiversity is been steadily declining, and as the human pressures on that biodiversity have been steadily increasing. Everyone talks about increasing temperature. This is a map of what's likely to happen in Australia, with up to about 5 degrees above global averages up to 1990, carrying over the remainder of the century. A pretty scary future. But what's even more scary is this. This is a map that's not so much the actual temperature, but how far outside natural variability that we're likely to go. And so those areas that are really red on that map are going way beyond what natural variability in temperature has been. So what are those sort of changes going to bring about in our natural ecosystems? What impact will it have on our biodiversity and what's already happening? Well, if you're a species and the climate changes and it suddenly becomes very uncomfortable for you, well, you've really got a few options. You can either move somewhere else if you're capable, you can adapt to that change, again, if you're capable, or you're going to die, you're going to go extinct. And an important factor that's going to mediate how that happens is how resilient is the species, and Terry was talking about how different coral species have different levels of resilience to the warm waters. But it's also going to be related to how buffered or how resilient different places will be in the landscape. Species are already moving. We had a whole conference about that about a year ago. All around the world, in every different ecosystem, every different type of taxonomic group, species are moving up hills, they're moving closer to the poles, they're trying to get away from these uncomfortable climates. And that's already having really big impacts on biodiversity, the functioning of ecosystems, and in fact it's affecting us as well. It's affecting human well-being. We had at that conference, we did a review and just found literally dozens and dozens and dozens of studies around the world in every different system where this was happening. Just to give you one quite small example, an important one, the climate changes, we get change in temperature, changing rainfall patterns, and increasing extreme events. One example, mosquito distributions have been moving with that change in temperature. And of course we all know that mosquitoes are one of the most important vectors of human diseases like malaria, dengue fever, and a whole host of other ones. As those mosquitoes have moved with the climate, that brings them into contact with millions more people that are now in contact with diseases that they weren't in contact with before, and of course that's resulting in higher prevalences of the disease and a lot of death. And that's also got flow-on benefits to the rest of society as well, because that means that we've got increased costs in governing the health system, increased costs of trying to eradicate these mosquitoes and the vectors, and of course a big decline in our own well-being. So things are moving all around the world, but it's not just the species that we're worried about. It's actually, it's affecting us as well. The predictions are that around the world, we could see something like between 60 and 40% of all species go extinct in the remainder of this century. I mean, that's a very scary number. That's more than a third of everything. Up until now, habitat loss has been widely considered to be the biggest threat to terrestrial biodiversity. We've all heard stories about how many football fields of rainforest are chopped down every minute and so on. And that's been completely true. But I would argue that now climate change is really taking over as the biggest threat to that global biodiversity. And even more importantly, it's the combination of those two things. It's the combination of the ongoing habitat loss and the future climate change. To give you an example of that, this is a recent study that we've done with a PhD student of mine in Thailand. That little graph on the right there is showing the predicted number of species that will become threatened, and in this case they're talking about rainforest birds in Thailand. And this is the number of species that will be threatened by future loss of habitat. So about 30, 40, 50 species will become threatened. How many would be predicted will become threatened from climate change? A lot more. It depends on how you look at that, whether you look at the change in their range size or the loss of their population, but a huge number more. If you look at the combination of habitat loss and climate change, it's a truly scary number. If you look at population declines predicted over the next 80 years, we're talking about out of a total of 310 species, about 280 becoming threatened. So it's like nearly 90% of all of the species in the system, with that combination of habitat and climate. Here in Australia, in the World Heritage Area that's right next to the Great Barrier Reef, a World Heritage Area that was cited as being the second most significant terrestrial World Heritage Area in the world because of our really unique species. And in the last 15 years of my research here, we've seen 50% of the species of birds and most of the rainforest possums, the things that are really iconic, the things that we actually made it a World Heritage Area to protect, they've already shifted up the hill, they've disappeared at the bottom of their range, and more than 50% of the species that the World Heritage Area is supposed to protect have now declined in their total population size. So Terry talked about the outstanding universal value. This is a huge impact on the outstanding universal value of the Wet Tropics World Heritage Area. So the really big question, and Terry also talked about this with the reef, what can we do? Well, it mostly depends on how much climate change we actually get. In other words, reducing emissions, other ways of mitigating. It will also depend on the resilience of species and places and how we can manage the change adaptation. And that's where a lot of the work that we've been involved in the National Climate Change Adaptation Research Facility, NCARF, is looking at that third point. So what do we need to know now that can maybe help us make better decisions about how to manage the future? Well, there's a whole range of things. In that diagram there, you can see that we really need long-term monitoring, we need good biodiversity science, we need to synthesise all that, we need good research, and all of that will improve our capacity to make good decisions. I'll give you an example of that, where we did some work that was facilitated by NCARF. It started out being an across the whole of Australia project. It was then focused on Queensland in collaboration with the Queensland Government. And their question was, what places in Queensland will help protect the most species under future climate? So, in collaboration with us and our group here at James Cook University, they did a big analysis and it came up with the best places to protect the most species across Queensland. They acted on that and they've now purchased 7 new national parks specifically aimed at maximising the retention of biodiversity in Queensland. So this is a really great outcome. Hopefully it will have a positive influence in the future as the climate gets worse. But it was really only possible because of that increase in the government's capacity to make really good decisions based on science. We've been involved in NCARF in trying to come up with other bits of important research, prioritising what is the national priorities for research in both terrestrial, marine and freshwater systems that will help us make good decisions. And this actually has a lot of overlap with some of the things that Terry was talking about in the reef. We really need to have new ways to approach conservation and resource management. It needs to be proactive, flexible and dynamic. The same old is just no longer going to cut it. We need to be able to integrate across multi-use landscapes where there's agriculture, primary industries, conservation, all happening in the same landscapes, all being affected by climate change. Really importantly, we need to manage existing threats. Again, similarity with the reef, talking about the threats of sedimentation and so on. In the terrestrial systems, we have lots of existing threats that people have been trying to fight for many years that impact on biodiversity and ecosystems already. And then how to manage specific systems, specific species that are threatened. So when we did this across all of the ecosystems in Australia, we did a huge stakeholder kind of engagement exercise within each of those different areas. And then we've come back to what are the 5 key things that we really need to know about in Australia. We need to understand the barriers to adapting to climate change, how we can change our general principles to be better under a future changing climate. Extreme events are really important, heat waves, droughts, fires, bleaching events on the reef. And then how do we identify the things that we can have the most impact on? How do we identify the places and the species that we can spend our money on and actually have some positive results, hopefully? And how can we change what we do under this new future? So I'd argue in the end that climate change is the most significant threat to global biodiversity, our natural ecosystems, but also to the global economy and human well-being. And we really need to act now to stop it. Thanks.
Thank you, Steve. So there are quite a few questions here about what happens when species move and about what happens where they're going, where they'll be competing with species that are presumably already there, which don't feel the same need to move or cannot move. What happens where they leave? Is a vacuum left? What comes in to fill it? Do you have greater biodiversity or less biodiversity? And what happens when you have an inequality between what's moving and what's not moving? For example, you know, if plants don't move but butterflies do, but butterflies need the plants, what does that mean? So
that sounded like about 50 years of research right there. Many things will happen. I mean, and it's we really don't know enough to be able to predict that. In some cases, an entire group of species may move together, but that's unlikely. Some species are more tolerant than others, so one species might move, another one might stay. And that will completely change the interactions, what they eat, what eats them, what plants they eat, where they live. So everything is going to change. We're going to end up with completely novel systems with novel new combinations of species. What happens when things move and there's a sudden vacuum? That's a good question. We've tried to look at that within the wet tropics. And when species seem to have moved with climate change in the past, in the rainforest, it doesn't look like anything else moved in. Over the time frame, there really was a bit of a vacuum. And in fact, the lowland rainforest here in North Queensland is still really quite poor species richness, probably because of these historical climate changes in the past. So it's a really tough question, and you know, to be honest, the answer to that is we don't know.
And what happens when, you know, the plants are static and the butterflies feel forced to move?
I think we're going to get both kinds of things happening there, in the sense that when an animal has to move and what it eats stays put, well, that animal will be in deep trouble. There'll be plenty of other examples, though, where they will adapt and they will change what they eat, they'll change their interactions. And it might mean that, you know, some species that have got that flexibility, that capacity to adapt how they go about their daily life, they might be in a better situation. But of course it also means that they'll be coming into contact with new species that might compete with them. But you know, there might be some winners as well. As they move into a new area, they'll do really well, and they might not have something that eats them, and they potentially will do a lot better. Of course, one of the really big things with the whole idea of movement and climate change is that these species are trying to move to maintain their comfortable climate. And the trouble is that people are in the way. We've already chopped up the landscape, we've cleared it, we've put roads in, we've got huge agricultural areas, and that where they want to get to, they often can't move.
And so there's a little bit of a question about that here. Is Queensland's effort to make more parks out of key species habitat a model that other states could use?
Oh, I hope so. I mean, you know, people have asked me, is it working? And I was like, well, come back in 80 years and I'll tell you. But the fact is that no matter what happens, we've at least given our best to make an informed decision that will try to protect the most species. We've modelled like several thousand species into the future to see where they would like to be and where their climate will be in the future. Combine that with these new national parks. Hopefully it will make a difference. And I think it's a positive thing no matter what happens. It's increasing the protected area estate, it's increasing the diversity of habitats across the state that's under protection. And yeah, I think it is something that other states and other countries could learn a lot from and hopefully do something similar.
There's a couple of questions here about adaptation options and just how viable they are. One about climate refugia and one about species translocation. Do you think, are they good ways forward? Yeah, well, I think
we've actually published a paper that was trying to identify what are the things that you can do, what are the decisions that managers can make, and one of them is, you know, are there refugia? And of course, I think that's going to be important. There are places in the landscape that are cooler or that are more stable than other places, and they might act as a refugia. They're not going to protect us from 6 or 7 degrees though, but they will make a difference up to a couple of degrees. I think that's really important. The next step in that decision is, can the species get there? And that's something that we've done a lot of work here in the wet tropics, where we've identified refugia that are going to be cooler, and then looked at corridors and movement patterns so that to see whether or not species can get from one place to another. And in fact, the Wet Tropics Management Authority has acted on that as well, and they've used community groups to start planting trees in areas that provide that connectivity to try to connect species up with where they need to go in the future. So yeah, I think refugia are really important. It'll depend though on what level we get.
Translocation?
Translocation is a much trickier one. Everyone always talks about it. You know, can we move possums from the wet tropics and put them in Tasmania? Of course, there's a whole lot of other things that live in Tasmania that might not like possums turning up and being released into their trees. And we've seen examples of that when possums have got into New Zealand, for example. I guess the way that I look at translocation is that I really hope that we never have to do it. I really hope it never becomes necessary, or even whether it's possible. But I guess what I would sort of mediate that with is by saying that maybe we should be doing some research now to work out whether it is feasible, whether it is possible, so that in the future, if we get desperate enough to need to do it, we'll at least know how to do it before it's too late.
Terry, did you want to speak to that?
Oh, just the refugia idea is something that's discussed a lot in the coral reef realm as well. If you look at the 4 bleaching events that have occurred in the Great Barrier Reef, I showed you a map of the 2 more recent ones, which have a different geography. The 2 earlier ones were different again. So after the 98 and 2002 bleaching, we thought that the northern Great Barrier Reef was a refuge because it didn't bleach in the first 2 bleaching events. And the amount of warming in the northern Great Barrier Reef is about half the rate in the southern region. So we thought it was a relatively safe place. It's the most pristine part of the Great Barrier Reef. Nobody goes there, it's remote. And then wham, in 2016, it really got decimated. And that, unfortunately, is a global pattern. Places that we thought were bleachings, when the average number of bleachings was 0, 1, or 2, that we thought were refuges, now that the average number of bleachings is 3 and 4 globally, fewer and fewer of those potential spatial refuges exist. And there's no relationship between the amount of average global warming and the number of bleaching events that have occurred in different places, because bleaching is caused by spikes of heat that are much less predictable than global average slow increases in temperature. So most of the IPCC trajectories for global average temperature in the sea are focused on summer maximums and the gradual increase due to global warming. They don't model very well, because it's much harder, the likelihood of extreme events occurring for a period of a few weeks.
Yeah, and I totally agree, and we get very similar analogous things in the terrestrial system, where it's actually like a heat wave which actually has the biggest impact rather than the increase. The Lemuroid possums, a population that we've been monitoring for years, just crashed after a heat wave. They've taken about 6 or 7 years to slowly start to come back to where you even see them. And it's the coincidence of one of these heat waves with a failed wet season when there's no cloud cover to keep that mountaintop cool. And when that happens, and if you look at the predictions and the sort of the trend line, that's going to happen again at some stage in the near future. And I couldn't agree more that those extreme events, those heat waves, they're the killer.
Yeah.
Steve, you've talked a lot about how things are going to look very different because species will move and some will become extinct. New species will come in. Do you want to put a time frame on that?
Well, most of the modelling, most of the predictions about extinctions that our group, and in fact most groups around the world, have usually been predicting up to about the end of the century. It's really hard to predict extinction, so what we tend to do now is to predict sort of when a species will have become critically endangered, less than 10% of its current population. How long they can hang on in a very small number is really quite difficult to predict. But So saying that, species can actually hang on longer. They can surprise us and be tougher than we think. But of course, on the other hand, as we were talking about before, we're not even taking into account all of these interactions with other things that make our predictions actually really conservative. Most of the things that we predicted here in the wet tropics are happening faster than the models predicted. They are moving earlier and more. The populations are declining more. And so the time frame, most of the predictions are based on the remainder of this century. Whether or not that will be, it'll actually be worse than that, though, remains to be seen.
So I'm getting the message from both of you that sooner than we thought.
Absolutely.
Yeah.
Absolutely.
So now just some more general questions that I'd be happy if you both addressed, but they're quite tricky ones. So, but here's a very important one. How do we make the environment important to politicians, to decision makers, to people who sometimes don't seem to care? Who's going to go first?
Well, I don't know, and it's really important because, in fact, that's one of the questions that I put up as when we went through our synthesis of the terrestrial, freshwater and marine priority areas of research, and then we had an expert panel rank all of these questions. The one that came out on the top was, what are the social barriers to getting adaptation and mitigation actions happening? And exactly that question, how do we convince people to do something? That's one of the biggest barriers that we have to overcome. How we do it, I don't know. Terry, do you have?
Well, it's a complicated question, and it's something I've thought about for a long time. It's complicated. So I think scientists like us two have a role to play in communication, and certainly the public interest and the media interest in the back-to-back bleaching on the Great Barrier Reef has been quite extraordinary. People are concerned. A big motivator, of course, is the social and economic impact on the tourism industry, on the fishing industry, which is still unfolding. So the tourism industry, of course, is deeply concerned about the loss of aesthetic values and about the possibility that tourists will be scared away if they think that all of the Great Barrier Reef is dead. And clearly it isn't all dead. There are still good parts of the Great Barrier Reef, and we need to get that message out as well. But reef tourism on the Barrier Reef alone is a $6 billion, $5 billion industry. It employs about 65,000 people. So reef tourism is the main economic reason why politicians should care. And I think many of them do. But there is a disconnect between Australia's energy policies for things like opening a new coal mine in Queensland, and the concern that I think many politicians genuinely have for the future of the Great Barrier Reef. We need to connect those two.
I sometimes think that unless we come to value the environment and ecology and biodiversity for themselves, we're never ever going to solve this problem. As long as we try to render it into political and economic terms, we're never going to crack this one. But that's just a position I've come to over the years, because like the two of you, I find no solution to getting politicians to value the environment, unless it has economic value. But
well, I saw a poll published today in a newspaper which says that only 7% of Australians favour the loan of $1 billion to Adani coal mine. So I think politicians will listen to public opinion before they'll listen to nerdy scientists like me. And if we can influence public opinion by talking to people about these issues, then I think we've got a role to play.
for sure, yes. A related question is, what can regular citizens do to protect biodiversity? Do you want to go first this time, Terry?
I actually think the focus on biodiversity is rapidly becoming outmoded.
Ecosystems are also mentioned.
Yeah. So The focus traditionally has been on saving species, and particularly endangered species. But I think in the future what we'll need to focus on is protecting functions, making sure we have enough predators in the system or enough herbivores or primary producers. So I think the trend in protection is not to conserve, preserve, restore, which is quite backward looking if you think about it. The world is on a conveyor belt thanks to global warming. We're going somewhere new. Assemblages of iconic ecosystems like rainforests and coral reefs are changing. They're changing very rapidly. And if our goal is to keep them the way they were 30 years ago, we'll fail. So I think business as usual will take us to a new system which will be very degraded. So the trick, I think, is to steer towards the future, towards an outcome that we can benefit from. And I don't think preserving ecosystems of the past is actually going to work. So it's in some sense it's an optimistic message that we can preserve functioning ecosystems, and I think that's the way we have to go forward. Biodiversity is that emphasis is quite a Western wealthy country construct, and as someone who works a lot in the developing world where coral reefs are all about food security and livelihoods, if I don't catch a fish, if I go fishing on the Great Barrier Reef, I go to the supermarket, right? It's not a big deal. But if you're a poor fisher in the Philippines and you don't catch a fish, your family goes hungry. And so people in different parts of the world have very different objectives in terms of preserving coral reefs. Biodiversity is a perfectly legitimate objective. Coral reefs have amazing aesthetic values. They're beautiful spiritual values. Obviously they're worth preserving, but there's also an economic and social side to it.
Steve?
Yeah, well, most I couldn't agree more. We are going towards a new future. Species are going to be either gone, or they'll be in places that they didn't used to be. They'll be in new mixes of species. I guess the term biodiversity, though, I wouldn't necessarily throw that out in the sense that I think biodiversity encapsulates everything that Terry just talked about. It does encapsulate the ecosystem functions which are maintained by biodiversity, and it doesn't necessarily have to be the same species that maintains that function, but we do need a functioning ecosystem, because not only does that keep the ecosystem itself functioning and healthy, it's also what supports human society as well. And so I guess I would use the term biodiversity in a very general sense. It's not just a focus about species, it's about species, the functions, the genetic diversity, and how that biodiversity keeps our world running.
And can you and I, well, no, myself and the audience here, what can we do? Can we contribute to this, or do we just do it through our opinions and through trying to influence decision makers in the system?
Personally, I think that's the most important thing that the general public, everyone can do, is to put pressure on our governments to reduce emissions globally, because that's really the only thing that's going to make a difference in the long run.
It's all the power we have. So on that note, I think I'm going to draw this webinar to a close. It's been absolutely fascinating for me. I've really enjoyed this afternoon, and I hope you have too. It is the last, so I would first of all like to thank Steve and Terry for a fascinating presentation, each of them, and also for the quality of the discussion, which has been fantastic. So thank you to both of them. This is the final webinar in this series, but if you want to watch them again, you can watch them on the NCARF website. It's been extremely successful. We've had a large number of people watching at the time and downloading afterwards. So I'm sure that NCARF will be taking this approach again and bringing you a new series of webinars in the future. Thank you very much for participating.